So today we are going to continue to look at the Lewis structures that we looked at yesterday in class and diagramming the bonds of our covalent compounds. So before we get to the new material, I just kind of want to do a little warm up to refresh your memory on the Lewis structures in general. Okay, so let's say we have the equation or the formula OCCl2. Okay, so here we have three nonmetals. That tells us it's going to be covalent bond, and we're going to be sharing our electrons. Go ahead and pause the video and try and predict what the Lewis structure, what the diagram for this molecule will look like. Okay, so go ahead and try and draw your Lewis structure for the bonds between these atoms to see how we did. So our first step is to figure out who's going to go in the center. And since carbon is in the center of our formula, carbon is going to go in the center of our molecule. So we're going to have one carbon surrounded by two chlorines and one oxygen. Okay. Once we figure out who's in the center, our next step is to draw in our valence electrons. So looking at the periodic table, chlorine is going to start off with 7. And that's the case for each of these chlorines. Oxygen is going to start off with 6. And carbon is going to start off with 4. Remember, our goal in doing these Lewis diagrams is for everybody to get up to 8. Okay, so everybody wants 8 valence electrons. So that means if chlorine has 7, each chlorine is going to want 1 more. So it's going to get that extra electron from our carbon. Okay, so our carbon is going to share 1 electron with each chlorine. So then now each chlorine has 1, 2, 3, 4, 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So each chlorine is happy. Likewise, oxygen has 6 valence electrons, so it needs 2 more. It's going to get those 2 valence electrons from that carbon in the center. So the carbon's going to move 2 of its electrons so that the oxygen can share those. So now looking at the oxygen, we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So now our chlorines have 8 and our oxygen has 8. Now we need to look at our carbon. Right now, carbon only has 4 valence electrons. Okay, so it's going to want to kind of pair up with the people that it gave electrons to. So if it gave an electron to chlorine, it's going to want chlorine to share 1 electron back with it. Okay, likewise over here, the second chlorine is going to share 1 of its electrons with that carbon. Okay, and we're not adding or removing any electrons. All we're doing is moving them around. So now if we look at carbon, it has 1, 2, 3, 4, 5, 6 valence. It still needs 2 more. So it's going to look to oxygen, who it shared electrons with, to share 2 of its electrons with that carbon. Okay. So now that carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Okay. So everybody ends up with 8. So we know here we can go in and draw our bond. So between our carbon and our chlorines, we're sharing 1 pair. So that'll be a single bond. Okay, we're sharing 2 electrons or 1 pair. That'd be a single bond. Between our carbon and our oxygen, there we're sharing 2 pairs or 4 electrons. So that would be a double bond. So we wanted to get this for our Lewis structure. Okay. So that was a little bit of a review of what we did yesterday. Today, we're going to look at some exceptions to the rules we followed in creating that Lewis diagram. So the first exception we're going to look at is the idea of having an incomplete octet. What this means is we want less an electron, 8 valence electrons, sorry. And there's going to be 2 in particular that we look at here. Boron is going to be the first one. Boron, he is so small that he can only hold 6 valence electrons. So boron only wants to have 6. Whereas beryllium, or Be, is there are other exceptions. He is even smaller, so he can only hold 4 electrons. So what this would look like then is if we had, let's say, BF3. So 1 boron and 3 fluorines. We'd put boron in the center, okay, because we only have 1 of him, and then put our fluorines around him. Okay. Boron is in the same group as aluminum, so boron would start off with 3 valence electrons, and we know fluorine is going to start off with 7 since he's a halogen. Okay, so if fluorine has 7, that means fluorine wants to gain 1 more electron, so it's going to share 1 of beryllium's. Okay, and that's going to be the case with each of our fluorines. Each fluorine is going to share 1 of boron's valence electrons, so now they have a total of 8. Likewise, boron needs 6 valence electrons. Right now it only has 3. So since it needs 3 more, and it's bonding with 3 fluorines, it is going to share 1 electron from each one of the fluorines. Okay. So now that boron has a total of 1, 2, 3, 4, 5, 6 valence electrons, which is how many valence boron wants. So since in each of these bonds we're only sharing 1 pair or 2 electrons total, these are going to end up being single bonds. We have a boron single bonded to 3 fluorine. Okay. Likewise, if we had beryllium and fluorine, like BeF2, Be would go in the center, since there's only one atom of beryllium. Looking at the periodic table, beryllium starts off with 2 valence electrons. We know fluorine starts off with 7. So that means fluorine needs to gain 1 more. So it's going to want to share 1 of beryllium's. So beryllium is going to share a valence electron with each of the fluorines. And then we know fluorine wants 4 valence. Right now it only has 2, but needs 2 more, which it's going to get from sharing with each of the fluorines. So again, since we're sharing 1 pair or only 2 electrons, we're going to end up with beryllium still bonded to our 2 fluorines. So that is going to be your incomplete octet. Boron and beryllium do not want 8 valence. Boron only wants 6 valence electrons, beryllium only wants 4. Okay. Opposite of that exception is going to be the idea of an expanded octet. So here, instead of having less than 8 valence electrons, we're going to have more. Okay, so these are going to be any elements after the 3rd row. So after the 3rd energy level, or 3rd row on the periodic table. Have more than 8 valence electrons. Okay. And the reason why that is because we now have those D sublevels that we remember from our electron configurations that are open. Okay. So after the 3rd energy level, we now have D sublevel that we have available to dump electrons in. All right, so let's look at an example. Let's say we have BrF5. Here, bromine will go in our center since we only have 1 bromine atom. And then around him, we'll put our 5 fluorine. We're going to follow these steps just like how we would any other problem. Okay, we know each fluorine is going to have 7 valence electrons, so we'll fill those in. And likewise, bromine is also a halogen. It's also only going to have 1 valence electron. Or sorry, 7 valence electrons. Okay, so we know each fluorine needs to gain 1 electron, and so does bromine. Okay, but here, since bromine can have more than 8, since it's past the 3rd energy level, and it's our central atom, we're going to focus on making our fluorines happy. Okay, so our fluorines need to gain 1 electron. That means each fluorine is going to form a single bond with our bromine. Okay, because we need to share electrons in order to form those bonds. Okay, so each fluorine is going to need 1 more electron, so it's going to share with 1 of bromine. Okay, so when we do this then, we end up with 5 fluorines singly bonded to that central bromine. And that's okay, because bromine is past the 3rd energy level, so as a central atom, it can have more than 8. Okay? Do not forget about this lone pair that was on bromine. So while bromine has these 5 bonds, it's also going to have 1 lone pair that's not involved in any of those bonds. So here, bromine actually ends up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 valence electrons. And again, that is A-okay, because bromine is past the 3rd energy level and is that central atom. Okay, so each fluorine needed 1, so we'll form a single bond there, leaving us with 5 single bonds and 1 lone pair, F4. So here our sulfur will go in the center, since we only have 1 of him, and we'll put our 4 fluorines around that sulfur. Okay. So here we're going to follow the same process that we did earlier. We'll fill in our valence electrons first. So each fluorine, again, has 7. So fill in those 7 valence electrons around each fluorine. And then since each fluorine has 7 valence electrons, each one needs to gain 1 more. Okay. So we're going to have single bonds again with our fluorine. Our sulfur, on the other hand, he is going to start off with 6 valence electrons. And we know that just by looking at the periodic table. So 1, 2, 3, 4, 5, 6. Okay. So since fluorine needs 1 more valence electron, it is going to form a single bond with our sulfur. Okay. So our fluorine and our sulfur will each share 1 with one another. Okay, because again, we need to share a pair in order for that bond to form. One person can't share, we both need to share. So when we end up doing this, we're going to see that we have 4 single bonds around that sulfur, so it has 2, 4, 6, 8 valence electrons. Then we also have this lone pair. Okay, so again, we have that lone pair that gives us more than 8 valence electrons. And that's okay, because sulfur is in the 3rd energy level, so we have that D sublevel available to us. Okay, and actually these expanded octets are going to be pretty easy to do because they're always going to have single bonds. You're not going to have to worry about double or triple bonds when working with the expanded octet. So that makes it super nice. So we know an ion has either gained or lost electrons. So a polyatomic ion is going to be a group of covalently bonded atoms that have an overall charge, which means we either gained or lost electrons. And we're going to say we either gained or lost electrons from your central atom. So from that atom in the center. Oops, I thought my pen died. Central atom. Okay, so let's look at an example. Let's say we look at PO4 3 minus. So that 3 minus tells us that overall we have a negative 3 charge, which means we gained 3 electrons. Remember, a negative charge, now we have more electrons, we gained those 3 electrons. Which means when we draw our Lewis structure, we are going to add 3 electrons to that central atom. Okay, so here our central atom is going to be phosphorus, since we only have 1 phosphorus. then we'll place our 4 oxygens around it. Okay, we're going to start this like we would any other. And we know oxygen is going to end up having 6 valence electrons, or start off having, sorry. So we'll draw those in around each oxygen atom. Okay. And then we know phosphorus is going to have typically 5 valence. However, since we have a -3 charge, that tells us we gained 3 electrons, and we're going to add those 3 electrons then to that central atom. So instead of having 5 valence, that phosphorus is going to have 8. Okay. So now that we've added those electrons to that phosphorus, okay, now we can look to see how our atoms are going to bond. Each oxygen has 6 valence electrons, which means it needs 2 more. So each oxygen is going to see that pair of electrons just sitting on phosphorus. And it is going to want to share those 2 electrons of phosphorus. Okay. So now each oxygen is going to have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons because it's sharing 2 from phosphorus. And lucky enough, phosphorus already started off with 8 valence electrons, so it doesn't need to gain any of oxygen. Okay. So if we're sharing 1 pair or 2 electrons, that's going to end up being single bonds. So we'll have our 4 oxygens connected via 4 single bonds. And then we need to show in this Lewis structure that we added those 3 electrons. So in brackets, we're going to put a charge of -3. Okay, that's to tell the reader that in this Lewis diagram, we had to add those 3 valence electrons to our phosphorus. Okay, let's look at another example. Let's say we had here NH4 plus 1. So if we have a +1 charge, that means we had to lose an electron. Because remember, if we have a positive charge, now we have more protons than electrons, so we had to lose an electron. So we lost 1 electron, so we're going, from our diagram, we're going to have to remove 1 electron from that central atom. So here, our central atom is going to be nitrogen, since there's only 1 of him. So put our nitrogen in the center with our 4 hydrogens around it. Okay. Nitrogen is going to start off with only 1 valence electron, whereas nitrogen typically would start off with 5. But since we have that +1 charge, that means we had to lose an electron. So instead of having 5, nitrogen's only going to have 4. So remember, hydrogen, the closest noble gas is helium. So hydrogen only wants 2 valence electrons. So hydrogen's going to need to gain 1. So it's going to want to share with 1 of nitrogen's. Okay. Likewise, nitrogen has 4 valence electrons. It needs 8. So it's going to want to share 1 electrons from each of hydrogens. So again, we'll end up with 4 singly bonded hydrogens around that nitrogen. And we need to show we removed that electron by having the +1 in brackets there. Okay, so now our nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, so it's happy. And each hydrogen has 2 valence electrons, so it's happy. Okay, so those are the 3 different types of Lewis structures that we're going to be looking at. Please let me know if you have any questions as you're working on your homework. Otherwise, I hope you guys have a fabulous rest of your day.